All right, simplifying complex fractions. We've actually done this stuff before, but just to kind of reinforce it here just a little bit before we go back into solving radical equations or rational equations. Again, this is just a giant division problem, okay? So when we've had it before, it was just like one thing stacked, like a quadruple stacked fraction. Well, now you're going to have to simplify both the top and the bottom, and then, so this is basically an addition or subtraction problem mixed with a division problem, okay? So again, you're going to want to kind of isolate each part. So first thing I like to do is I like to put the top and the bottom together each into one equation. So I'm going to start with the top, okay? To be able to put those together, I have to have common denominators, and this one's pretty easy because it's just numbers, okay? I could change this one into a 6/8 minus a 1/8, and that's going to give me 5/8, okay? I'm going to do kind of the same thing to the bottom down here, finding common denominators between basically a 1, remember, and a 12. So this is going to be 24 over 12 plus 1 over 12 is going to be 25 over 12. So this is now this is the type of rational complex fraction we've seen before. We do, remember, leave the top thing the same, change it to a multiplication question, and flip the bottom. Okay. Now since this one does just have numbers, you could just multiply straight across the bottom and the top and simplify. I'm going to reduce. So I know 5 goes into 25 5 times. I know 4 goes into 8 2 times and into 12 3 times. Now when I multiply straight across the top, that's 3 over 10. Okay. You can kind of do this in a couple different ways. You can maybe skip some steps in here and go straight from here to here, but you just need to be really careful, and it kind of depends on your question. So number 2, again, I'm going to leave my first equation the same. I really can't do anything to that yet. It's already combined. For the bottom part, I do need to put those together. To do that, again, this is over 1. I'm going to have to multiply this one top and bottom by x. Okay, so now this is 6x plus 4 over x. Okay, again, to simplify that, I leave the first one the same, x plus 2. I change that to multiplication, and I flip my other one. So the x goes on top, the 6x plus 4 goes on bottom. Okay, now normally at this point, I would recommend that you factor any of these denominators. So like here, I know I can take a 2 out. That actually, in this case, doesn't really help me very much, but sometimes it might end up canceling something. Here, I end up with just an x on top and a 2 times 3x plus 2 times x plus 2 on bottom. Again, I really don't recommend multiplying the bottoms back out. It just is usually pretty unnecessary. Okay. Question number 3, kind of same thing. Top one's pretty easy. All I have to do is multiply the top one by 2. So that's a 2 over 2x plus 3 over 2x is going to be 5 over 2x. Okay. For the bottom, looking down here, I have a 3x and a 4x, so they both already have x's. I just need to multiply the first one by 3. No, that's not true, by 4, and the second one by 3. So that becomes 4 over 12x plus 9 over 12x. At this point, this is a point where I might go ahead and skip a step and say, well, I already know what that's going to be and flip it, but just for note's sake, I'm going to keep going this way. 13 over 12x. Again, first equation stays the same. I change it to multiplication and flip the second. And then I simplify from there. So I can cancel out my x's. Okay, 2 goes into 12 6 times. Multiply straight across the top is 30. Straight across the bottom is 13. Now, if you skipped that step and you, right here, you couldn't reduce it, you wanted to multiply straight across the top first, then straight across the bottom, then reduce, that would work just fine. You just would probably have an answer at the end that could be reduced further. Okay. So same thing here in question number 4. Again, I'm going to start with the top. Okay, to be able to add those together, I need to change that 1 into an x minus 1 over x minus 1. Now plus 1 over x minus 1. Okay, skipping a couple steps there, I know my denominator is just going to be an x minus 1. For the top, x minus 1 plus 1 is going to simplify to be just x. Okay, kind of similar thing on the bottom. I'm going to have to change that to an x squared minus 1 over x squared minus 1 plus 1 over x squared minus 1. Again, when you simplify that, this is going to be x squared minus 1 plus 1 is just going to be x squared over x squared minus 1. Okay. Again, setting up for the second part of this, top equation stays the same, x over x minus 1. I change it to multiplication, and I flip the second one, x squared minus 1 over x squared. Okay, looking at reducing here, I can factor this into x plus 1 and x minus 1. These x minus 1 terms are going to cancel out. This can cancel out too. This x cancels out one of these, and I'm left with just x plus 1 over x. Now don't get crazy. I know canceling is fun, but you can't cancel that any further. Done. Okay. Similar thing here on the back, so I'm just going to keep going. If you got it, there's really nothing else crazy that happens on this. The questions just get a little more complicated, but it's up to you. Next question, again, I'm going to kind of do the same thing. I'm going to have to make these both k minus 2's. So the top of this one's going to be k times k minus 2, 2 over k minus 2, plus 1 over k minus 2. Okay. When I get ready to simplify that, I know the bottom's just k minus 2. For the top, I'm going to have to do a little bit of work. So if I distribute that, that's k squared minus 2k plus 1. There's nothing else I can do to that. So k squared minus 2k plus 1. Okay. Similar thing down here when I do this one. Again, that's just k squared over k minus 2 plus k minus 2 over k minus 2. That's what 1 is. Again, when I simplify that, I get just k squared plus k minus 2 over k minus 2. Okay. At this point, you might already see that these are the same and that they're going to cancel out, but just for argument's sake, I'm not going to do it. I'm just going to go ahead and write this equation exactly like it is. Don't be a hero. Sometimes it's easy to make mistakes because you think something can cancel and it doesn't. So it's a good idea to check. But looking here, I do see those k minus 2's cancel. For the rest of this, I'm going to factor this. That's k minus and k minus multiplies to be 1, adds to be 2. That's 1 and 1. This is k plus and k minus multiplies to be 2, subtracts to be 1. 2 and 1. Our k minus 1's cancel. And I'm left with just 1k minus 1 over k minus 2. Okay, cool. Lots of k's going on. Question number 6, again to find common denominators. Looking at the first one, so this is like just basic, you just have to pay attention to how to find common denominators. They both already have a y, okay? I just need to multiply this one by another y, so I have a y squared, and this one by an x, so I have an x in there. So this becomes just y minus x over xy squared. So I kind of skipped one little tiny step there, but I'm not too worried about you figuring that out because I have faith in you. Here, kind of similar thing. This one has an x squared, this one has an x, so it needs another x. This one has a y squared, this one just has a y, it needs another y. That becomes y minus x over x squared y squared. Again, when I flip this one, y minus x over xy squared times x squared y squared over y minus x. This is such a fun question. Quick note here, for argument's sake, if this was maybe in the wrong order, you know, like right now they're the same and I could tell that they're going to cancel out, but if this one down here was like maybe x minus y instead, you could still make them cancel if you factored a negative out. Okay, now if that's negative y minus x, that's not going to work. But if the letters were just in the wrong order, the wrong term was negative, if you factor that negative one out, you will get the same thing. The y squareds are going to cancel, this x cancels one of these, and this whole crazy equation simplifies to be just x. Okay. Just a couple more to keep going. This one, again, the top equation is already ready to go. So 2x over x squared plus 4x plus 3 over, now I know the only way to make the bottoms the same here are to multiply them by the opposite one. So this one times x plus 1, this one times x plus 3 on top and bottom. Okay. So I know already that that's going to make my denominator here an x plus 1 times an x plus 3. Okay. For the numerators, I'm going to come over here to the side and do some work. So that's 4 times the x plus 1 plus 2 times the x plus 3, just to simplify my numerator for that one. So that's 4x plus 4 plus 2x plus 6. Combining like terms, that's a 6x plus 10. Okay, cool. Now finishing this off, again, the first equation stays the same. X squared plus 4x plus 3. Change it to multiplication. Flip in the second one. And then I highly recommend factoring at this time. Again, that's the x plus. Oh, that's so shocking that it turns into plus 3 and plus 1. So this whole thing cancels this whole thing. Okay, I can actually factor a little here too. For example, I could take a 2 out. That leaves me with 3x plus 5. This 2 and this 2 are going to cancel. So my answer here is just x over 3x plus 5. Okay. How about one last equation? You're so excited, I can tell. Top equation, done. I can't do anything to that. X squared minus 4. This one, the only thing I need to do to make those the same is multiply this one by 2. Okay, so that is going to be, if I did 2 times 4 is 8 plus 2. So that's 10 over 2 times x plus 4. I'm going to leave it factored out. Sorry, 2 times x plus 2. Wow. I said I'm going to leave it and then I do it wrong, but you know, that's okay. Again, same type thing. Top one stays the same. Bottom one we flip. Do a little bit of factoring. That's x plus 2 and x minus 2. X plus 2 is canceled. This 2 goes into this 10 5 times. When I simplify, that leaves me 3x on top and 5 times x minus 2 on the bottom. You really could distribute that 5 through there, but I just say completely unnecessary.